Hi everybody, in this lesson I will help you understand how to generate equivalent fractions of a given fraction. So let's get started right away with an example. So we have this picture here that shows a whole circle divided into three equal parts. So this is the fraction 2 over 3, and now if you look at this picture over here, what's really happened here is that each of these three parts has been further divided into two equal parts. So if you look at this part, for example, this part over here has been divided into two equal parts, and that's been done for all of the three parts. So the number of parts, the total number of parts and the number of shaded parts have both doubled. So the total number of parts here has become 6, and the shaded parts, that number has become 4. So this is the fraction 4 over 6, and we can get from 2 over 3 to 4 over 6 by multiplying both the numerator and the denominator by 2 like this. And we can clearly see from the picture here that these two fractions are equivalent because the shaded part represents the same portion of the whole. So that's the key idea here. To generate an equivalent fraction of a given fraction, you can multiply the numerator and denominator by the same number to get another fraction that is equivalent to the original fraction. Now let me help you visualize this better with a simulation. So here is a simulation with this original fraction 2 over 3, and this is the equivalent fraction that we will get by multiplying the numerator and denominator here with the same number. Right now we are multiplying with 1, so the equivalent fraction is still 2 over 3, but let's increase this number. So first we go to 2, so you can see now this equivalent fraction is 4 over 6, a different fraction but represents the same portion of the whole, so it is equivalent to the original fraction. Now let's increase it further. So now we are multiplying above and below by 3, so we get 6 over 9. So that's the fraction over there, but again it is still equivalent to the original fraction. Let's do one more. Let's maybe multiply with 7 above and below, so we get 14 in the numerator and 21 in the denominator. So you can see that the whole has been divided into 21 equal parts now, with 14 of them shaded, so it's 14 over 21, but it is still equivalent to 2 over 3. So that's the key idea. You multiply the numerator and denominator by the same number, you get a new fraction which is equivalent to the original fraction. Now let's take a look at this second example here, which actually has an improper fraction 3 over 2. So if you look at this picture here, this rectangular block represents one whole, and we've actually taken two of the holes and three parts are shaded. So the number of parts into which a whole is being divided is 2, and therefore the denominator is 2, but three of the parts are shaded, so the numerator is 3. So this is an improper fraction 3 over 2. Now the question here is, can we still do the same thing of multiplying the numerator and denominator by a certain number to get another equivalent fraction? The answer to this question is yes. For example, we have multiplied the numerator and denominator with 3 to get a new fraction 9 over 6. So what is this really doing? It is dividing each of these parts further into 3 equal parts. So as you can see here, you have now each whole being divided into 6 equal parts and 9 parts are shaded. So this picture here represents the fraction 9 over 6. It's a new fraction, but it is equivalent to the original fraction 3 over 2 because as a portion of the whole, the same portion is shaded. So this 9 over 6 therefore is equivalent to 3 over 2. So let me once again help you visualize this concept for improper fractions through a simulation. Okay, so here's my simulation with this original fraction 3 over 2. And here I will get my equivalent fraction when I multiply the numerator and denominator by the same number. Right now that number is 1, so my equivalent fraction is still the same as the original one, but now I will start increasing this number. So let's move it to 2. Okay, so what do I get now? So I get 6 over 4. So each whole is being divided into 4 parts and we have 6 parts shaded. So this is 6 over 4, but you can see that it is equivalent to 3 over 2 because the same portion is shaded. Now if I increase it to the multiplier to 3, I get 9 over 6. Again, this is equivalent to 3 over 2. So I can keep doing that and I can generate as many equivalent fractions as I want. Let's take maybe one more example. Let me set this to 5. So I'm multiplying above and below by 5. I get 15 over 10. So this is that fraction. This visual here represents 15 over 10, but you can see that it is equivalent to 3 over 2. So once again, the concept is you can take any fraction, multiply the numerator and denominator by the same number, you get another fraction that will be equivalent to the original fraction. Okay, now we will solve this question. What are the missing numbers? So we have this fraction here, which is 3 over 4. Why is that? Because the whole has been divided into 4 equal parts, 3 of them are shaded. So this is 3 over 4. Now what is happening over here? So you can see that each of the parts here, for example, this part has been divided further into 3 equal parts, and therefore we get this equivalent fraction here, which is 9 over 12, because now we have 12 equal parts and 9 of them are shaded, so 9 over 12. So what is really happening here? We are multiplying the numerator by 3 and we are also multiplying the denominator by 3 to get this new equivalent fraction, 9 over 12. So the missing numbers here are 3. Okay, select all the equivalent fractions of 5 over 6. So we need to see which of these fractions we can generate from 5 over 6. So the first one is 25 over 35. So I take 5 over 6 and then I'll multiply both the numerator and denominator by 5, let's say, and this gives me 25 over 30 as the equivalent fraction in this case. But here I have 25 over 35, so this is not really equivalent to 5 over 6. Now what about 10 over 12, this one over here? So I can multiply above and below by 2. So 5 times 2 is 10, 6 times 2 is 12. So yes, this indeed is equivalent to 5 over 6. What about 20 over 24? So if I multiply 5 over 6 above and below by 4, I should get this, because 5 times 4 is 20, 6 times 4 is 24. So yes, this is equivalent to 5 over 6. What about 10 over 11? Well, if you multiply 5 by 2 and 6 by 2, you get 10 in the numerator, but 12 in the denominator, which is what we got here. So 10 over 11 is not really equivalent to 5 over 6. So two fractions here are equivalent to 5 over 6. Write 3 equivalent fractions for 8 over 7. So very straightforward. We have our original fraction 8 over 7 and we have to generate 3 equivalent fractions to this. So we can simply multiply the numerator and denominator with the same multiplier, and we can take different values of the multiplier. So let's multiply above and below by 2 first. So that gives me 16 over 14. So that's one possible equivalent fraction. Let's multiply above and below by 3. So 8 times 3, 24, 7 times 3, 21. So 24 over 21 is another possible answer. Let's multiply above and below by 10. I could take any value I want, so I'm taking 10. So I get 80 and 70. So 80 over 70 would be another possible answer. Okay, let's keep going. Divide the numerator and denominator by a common factor. So what this slide is really telling us is, just like we can multiply the numerator and denominator by same number to get an equivalent fraction, we can also do the reverse. We can divide the numerator and denominator by the same factor to get an equivalent fraction. And it's very easy to see why that works. For example, in this case, you have this fraction here, 8 over 12, because you have 12 equal parts, 8 of them are shaded, and this here is the whole divided into 6 equal parts, 4 of them are shaded, so this is 4 over 6, and you can clearly see that the 2 of them are equivalent. And what's happening here is, if you divide the numerator and denominator both by 2, you go from 8 over 12 to 4 over 6. So this is also a way to generate equivalent fractions. You divide the numerator and denominator by the same factor to get another fraction that is equivalent to the original fraction. In this case, you have 8 over 12 as the starting fraction. Divide above and below by 4. So you get 2 in the numerator, 3 in the denominator. You get this new fraction 2 over 3, and clearly you can see that this is equivalent to the original fraction. So you can either multiply the numerator and denominator by the same multiplier, or you can divide the numerator and denominator by the same factor, and in both cases you get an equivalent fraction. Okay, here's our next question. What are the missing numbers? So in this case, we have this picture here that represents the improper fraction 9 over 6. So this is one whole divided into 6 equal parts, and we have 9 parts shaded, so we have 9 over 6. And here we have an equivalent fraction 3 over 2. So you can see that the same region is shaded here as what's shaded over there. And how do we go from here to here? So we can divide the numerator and denominator by 3. So you can observe it from the figure as well. For example, if you take these 3 parts, here you have a single part over here. So you divide the numerator and denominator by 3. So divide by 3, divide by 3. So 9 goes to 3 and 6 goes to 2, and you get this equivalent fraction 3 over 2. Alright, select all the equivalent fractions of 18 over 24. So we will see which of these fractions we can generate from 18 over 24 by dividing above and below with the same number. So let's do the first case in more detail. So we have 18 over 24. Can I generate 2 over 4 from 18 over 24? So if I divide the numerator by, let's say, I need 4 in the denominator, so let's divide the denominator by 6, but I'll also have to then divide the numerator by 6. So what I'll get is 3 over 4, but that is 2 over 4, so 2 over 4 is not really equivalent to 18 over 24. What about 6 over 8? I think I can get that. If I divide above and below by 3, I'll get 6 here and 8 here. So yes, 6 over 8 is indeed equivalent to 18 over 24. What about 8 over 14? So doesn't look like I can get from here to that fraction. So no, 8 over 14 is not equivalent to this fraction 18 over 24. And then what about 9 over 12? Well, let's see. If I divide above and below by 2, so 18 goes to 9, 24 goes to 12, and therefore I get this 9 over 12, which is therefore equivalent to 18 over 24. Okay, write 3 equivalent fractions of 8 over 72. So what we'll do in this case is, we have this original fraction 8 over 72, and we will divide above and below by the same factor to get another equivalent fraction. So let's first divide by 2 above and below. So 8 becomes 4, 72 becomes 36. So 4 over 36 is one possible answer. Let's divide above and below by 4 now. So 8 by 4 is 8 divided by 4 is 2. 36 divided by 72 divided by 4 is 18. So 2 over 18 is another possible answer. And now let's divide above and below by 8. So 8 becomes 1, 72 becomes 9. So I get 1 over 9, which is yet another possible answer. So these 3 fractions are all equivalent to 8 over 72. Now here's a problem of a type that we often see when it comes to equivalent fractions. You have 7 over 8 on the left here, and it says 7 over 8 is equal to some fraction on the right side, but the numerator of this fraction is missing, and this equal to sign is telling us that these 2 fractions are equivalent, and we need to find the numerator over here. So how do we do this? The systematic way to solving this is shown over here. We start with the denominator because we know both the denominators. So we have 8 over here, and we need to get to 16. So how do we go from 8 to 16? Well, we need to multiply by 2. If we multiply it by 2, we get 16. So we write times 2 over here, but we'll now need to do the same thing with the numerator. We'll also need to multiply the numerator by 2. So 7 times 2, that gives us 14 over here. So 7 over 8 is equivalent to 14 over 16, and therefore this question mark here will be the number 14. Now let's see a few more questions of this type. Okay, find the missing values. So I have 44 over 20 here, and I have something over 5. So how do I figure out this missing number over here? So I can see that to get from 20 to 5, I have to divide by 4. So I need to do the same thing over here. So I need to divide by 4. So 44 divided by 4 is 11. So 11 over 5, 11 is the answer over here. What about here? So 24 is going to 3. So this is essentially being divided by 8. So I need to divide the denominator also by 8. So 56 divided by 8 is 7. So 3 over 7 is what we get on the right over here. And then 49 over 63 is equivalent to what here? So I will divide 49 by 7. to get 7. So I'll need to do the same with the denominator. So 63 divided by 7 is 9. So 9 is what will show up over here. So that's it. That's the concept. That's how you generate an equivalent fraction from a given fraction. You either multiply the numerator and denominator by the same number, or you divide the numerator and denominator by the same number if possible to get an equivalent fraction. So that's the whole concept. I hope you understood it. Thank you for watching.